Alright, today we're writing polynomials with imaginary zeros. And you wrote polynomials for the 5A test, so this is something you've seen before. We're starting with a warm-up. And the warm-up says to factor. Notice it doesn't say to solve, it just says to factor. And the quiz that you have coming up next week, next Wednesday, you will also be factoring. And so we'll start with our box. We have a fourth power here. And we're going to put our first term in our first box. So the 4x to the fourth goes in the first box. The negative 9 goes in the last box. And when we multiply those together, we're looking for factors that multiply to be a negative 36x to the fourth and add to be your middle term of 35x squared. And so if I use a negative 1x squared and a positive 36x squared, those factors multiply to be negative 36x to the fourth and add to be 35x. And so I'm going to put the negative 1x squared in one of the boxes and 36x squared in the other. And it doesn't matter which one goes where. And then I'm going to take out the greatest common factor. So between the 36x squared and the negative 9, those both divide by 9. This edge is positive, so I'm taking out a positive. Here I can take out 1x squared or just x squared between those two. Vertically I have a 4x squared and also a negative 1. Okay, and again it's negative because that edge is negative. And so for number 1, when I factor the first time here, I have x squared minus, or excuse me, x squared plus 9, not minus 9. It's positive 9 times 4x squared minus 1. Okay. And we know there's no special pattern for the sum of two perfect cubes, or excuse me, two perfect squares. There is a pattern for perfect cubes, but not for perfect squares. And so there's nothing I can do with x squared plus 9. There would be nothing that multiplies to be 9x squared that adds to be 0. It would have to be a negative 9. But the 4x squared minus 1 is the difference of two squares pattern. If we square root 4x squared, you get 2x. And if we square root 1, the square root of 1 is 1. So we have 2x minus 1 and 2x plus 1. And you can also do that in a box if you need to see that visually. But there's your first warm-up. Number 2, the first thing I notice is that there is a greatest common factor. Both terms divide by 2. And so if we take out a 2, we're left with x cubed minus 8. Okay. Now this is the pattern that you learned with me last week. This is the cubes pattern. 8 is a perfect cube because 2 times 2 times 2 is 8. And x times x times x is x cubed. And so we're going to bring our GCF down, and the first part is the binomial part. We have an x minus 2, so we have the cube root of x cubed, which is just x, and the cube root of 8, which is 2. That's the binomial part. And then remember, you're going to have a trinomial that's based on the binomial. So remember, we call this a, and we call this b, and you square a, so x squared is just what it sounds like, x squared. And we take the a times the b, and so 2 times x is 2x. And then we square the b squared, 2 squared is 4. And remember, for our pattern, it's always plus if it's the difference pattern. Alright, and once we have this done, it will not factor any further. Anytime you have the cubes pattern, if we were finding zeros, we'd have to do the quadratic formula because this will not factor with a box. Alright, and remember this pattern with the a minus b and the a squared, ab, and b squared will be given to you on the quiz next week. For number 3, one last time, another difference of squares pattern. So this looks a lot like x squared plus 9, except that it's the difference pattern. And for perfect squares, it has to be minus. If it's cubes, though, it could be plus. So on number 2 here, if this would have been a plus sign, we could still factor it. It just would be the sum pattern. Now remember, for the difference of squares, you shouldn't need your box anymore. But really quickly, in case you forget the pattern, you're looking for what multiplies to be negative 9x squared that would add to be 0 in the middle. There is no middle term. And so we would use 3x and negative 3x, because 3 and negative 3 would multiply to be negative 9 and add to be 0. And so this is the difference of squares pattern. If we square root each thing, that is x plus 3 and x minus 3. All right, the last part of your warm-up today is going to help you with the lesson for today, which is writing a polynomial in standard form with the given zeros. So we know x is equal to a negative 2, x is equal to 0, and x is equal to 3. We have 3 solutions, so we would expect this to be a cubic, the third power, once we get everything done. And so we're going to set this up. X equals a negative 2 is the factored form of x plus 2, because when I said x plus 2 equal to 0, I would get x is negative 2. I'm going to have x minus 3 to get x equals 3, because we would add 3. And then remember, anytime you just have 0, that's a GCF. And so you can say f of x equals or y equals. This is your polynomial in factored form. But we need to get to standard form, so we need to multiply. So I'm going to take my first term times my first term. That gives me x squared. X times a negative 3 is a negative 3x. And I'm going to distribute the 2 through, so 2 times x is 2x. That's a positive 2x. And 2 times a negative 3 is a negative 6. Okay. And then I bring my GCF down. Remember, you can only multiply 2 at a time. And so we have our GCF of x. And then I'm going to combine my like terms. I have a negative 3x and a positive 2x. They combine to be a negative 1x minus 6. All right, we have a quadratic times x now. And so if we multiply one more time, we'll have the cubic that we are anticipating. So x times x squared is x cubed. X times a negative 1x is a negative 1x squared. And x times a negative 6 is a negative 6x. And so this would be the original polynomial in standard form that would give the zeros. X is negative 2, x is 0, and x is 3. All right, and like I said, all of the warm-up things you've seen before. For notes today, I want you to know that imaginary numbers always come in pairs. So we talked about imaginary numbers right before finals first semester. So just as a reminder, I squared is a negative 1, and you won't need this for this lesson, but remember the square root of a negative 1 is I. So anytime you have a negative under a square root, it comes out as I. But if you have I squared, in other words, if we square both sides, the square and the square root would cancel, and we know I squared is just a negative 1. So whenever we see an I squared, we can replace that with a negative 1. All right, so the new thing for today is that when you write your polynomial in standard form, you need to remember the imaginary numbers come in pairs. So if you're given a negative 2i as a 0, so we know x is negative 2i, it's assumed that you will know x equals positive 2i as well, even though it's not given to you, because the imaginary numbers always come in pairs. And then we're also given x is 3. All right, and again, we have 3 zeros here, so we should expect to have a cubic when we're all done, just like the warm-up. So I'm going to say y is equal to, and we're going to have x minus, and then we're going to write the 0. So we're going to have x minus, and normally if you just have a number like 3, we would write x minus 3. And if we were to solve that, if we were to set that equal to 0, we would add the 3 to get x is 3. We're going to have x plus 2i, which would give us x equals negative 2i if we were to solve. And we're going to have x minus 2i, which would give us x equals 2i. So that is the factored form. But notice the directions say you need to write this in standard form. So right now we're in factored form. And we're going to have to multiply to get to standard form, just like we did in the warm-up. Now, the imaginary numbers you're going to want to multiply together. So don't multiply the x minus 3 with the x plus 2i. It can be done, but it'll give you a lot more of a headache than if you do the imaginary numbers together. So we're going to multiply the two imaginary factors together first. So x times x is x squared. X times a negative 2i is a negative 2ix. Okay, we're done with the x. Now we're going to distribute the 2i to both terms. So 2i times x is positive 2ix. And 2i times a negative 2i is a negative 4i squared. So the 2 times the negative 2 gives you the negative 4. The I times the I gives you the I squared. And just like with the warm-up, we're going to bring the x minus 3 down, just like we brought the x down. And I'm going to look for like terms. The negative 2ix and the positive 2ix cancel. And we're left with the factor we haven't used yet, x minus 3. And then we have x squared
minus 4i squared. But remember that I squared is equal to a negative 1. And so I'm going to replace the I squared with a negative 1. So I have minus 4 times a negative 1, which is really x squared plus 4, because a negative 4 or a minus 4 times a negative 1, a negative times a negative is going to make this plus 4. And so we're going to multiply one last time the x minus 3 with the x squared plus 4. Notice all the i's will be gone once we're done multiplying. If you still have an I left, you've done something wrong. We have x that we're going to multiply to both terms, and the negative 3 that we're going to multiply to both terms. So x times x squared gives you x cubed. X times 4 is 4x. Negative 3 times x squared is negative 3x squared. And negative 3 times a 4 is a negative 12. And the last thing we need to do is just make sure that this is in standard form and that the variables are in the right order. And we want the powers in descending order. So we want the x cubed first, and then the negative 3x squared, and then plus 4x, and then minus 12. So that is how you write a polynomial function in standard form given zeros. And when you have imaginary zeros, it's just a little bit more work. I'm going to pause here